Welcome to the VeloCloud SD-WAN for Service Providers Learning Series. Part 2, VeloCloud Service Provider Topologies and Use Cases.
So in terms of topology, the product consists of three main elements. The VeloCloud product consists of three main elements. First, as we talked about before, there is a VeloCloud Edge that goes at the branch. And we have multiple flavors of the VeloCloud Edge. And the VeloCloud Edge comes either in a hardware form factor. The first portion of our solution consists of the Edge. And then the second piece are the gateways. And these gateways can reside either in our cloud or in a private cloud. And then finally, the third element is the orchestrator. So those are the three main elements. Now, what I'm depicting here in this topology slide is our enterprise deployment. And you'll notice that it's our cloud. And you'll notice in the two examples here on the right, we have an example where we're terminating an IPsec tunnel directly to this data center without a VeloCloud Edge. And then in this case below, we actually have a VeloCloud Edge. I want to describe the difference between these two. And this is what I would characterize as an enterprise deployment, where the service provider hasn't deployed our solution into their network. They're maybe providing this to their customers as an overlay. And this is a way to get to market very, very quickly. So in the case where you don't need the VeloCloud Edge, this is simply using broadband services. So we are logically connecting to one or more of these gateways. And as I mentioned before, we're able to do all that measurement between gateways. But then, in order to get access either to the SaaS location or to the enterprise location, you're basically just building the tunnel from our cloud to that data center, or you're accessing the SaaS service, because typically these gateways, our gateways, are co-located in the same location as the SaaS services. So we're able to basically provide that high-performance remediated link all the way up to the point where you're accessing that cloud service, whether it's Salesforce, Blue Jeans, or whatever service that you're accessing. In the example below, this is where we're providing a hybrid WAN connection that consists of both internet as well as MPLS. And in this case, we're building the tunnel. We're building a tunnel across MPLS. We're building a tunnel across internet, and it's terminating physically instead of logically, as I talked about earlier. It's terminating physically on our VeloCloud Edge. And in that case, we're able to measure both the MPLS as well as the internet, and we can do the same level of traffic steering across both those links. We're also able to nail up traffic and pin traffic to certain links. So if you want, as an example, if you decide that you want all of your PCI traffic to be pinned to the private link and your internet and SaaS traffic to go across the internet, you can do that through our business policy framework. So these are the two topologies that we support with regard to enterprise. What I think is more interesting for service providers is the ability to deploy our gateways into the service provider cloud network, or the service provider core network. So in this case, as you can see, we're deploying our gateways in the same POPs that the service provider's PE routers exist. And the reason why this is important, as you can now see, is that we can offer augmented MPLS to the service provider. And this is the ability for us, again, to build tunnels across both MPLS as well as across the internet, leverage both of those links in order to provide this augmented MPLS. And when you get to your data center, you don't need to put a head-end device there. So what does this mean for the service provider? This means, first of all, the service provider can provide an augmented MPLS service, right? And I'll give you an example. If that particular customer is running a 1.5 meg, if you're in the US, a 1.5 meg T1 connection, MPLS connection, or if they're in Europe, it's a 2 meg E1 connection, and they need to augment that and increase the bandwidth, but it's cost prohibitive. The service provider can now offer a 10 meg broadband connection, and we, as I mentioned before, we will aggregate those two together and create a logical aggregated circuit where we can do all that dynamic packet steering and forward error correction. But this provides the customer with an augmented MPLS pipe. Or If that customer has many other locations that are pure internet, now you can onboard pure internet locations to your private MPLS cloud using our cloud gateways. So that's the first advantage, is now you have many more options that you can offer your customer versus losing that customer to your competitor that's offering as an example, a broader, higher capacity broadband service. So this is a way to augment MPLS. Additionally, as I mentioned before, you don't have to have that head-end device at the data center. This allows you to move into revenue much quicker. Your POCs will be much quicker. All you have to do is drop ship a VeloCloud Edge, build the tunnels, which takes all of about 15 minutes, and then turn the service up and go into POC, and then move into revenue as you prove the service out for your customer. The most obvious, I guess, product that can be introduced with VeloCloud is this new tier of global service. And I say global services because we are agnostic, and therefore the operator and the service provider can be agnostic to who's actually delivering the service. So just to give you an example, if you have a customer that is using MPLS worldwide, well, certainly MPLS is going to give you the most predictable performance, right? And so in this example here, we're just mapping out MOS scores, right? So with MPLS, MOS scores are going to be very, very high, and this network is going to be able to handle VoIP traffic very easily. Now, it's high cost, especially when you're talking about a multinational network, because if you go to, as I mentioned before, if you go into Asia, you're talking thousands of dollars or $1,000 per megabit for MPLS service. We're seeing that down in Southeast Asia and Australia and those locations. But again, you get a very predictable performance. You can bound it by SLAs, and your most critical and discerning enterprise customers are going to want this type of service in order to guarantee that performance. Now, the option is using, basic internet. Now, while internet has high coverage, you can get high capacity, it's a shared infrastructure, and it's going to have unpredictable performance, in some cases poor performance, but it is the lowest cost. Now, if you look at the actual MOS scores that you can derive from a pure internet network, you'll see that only 60% of the time will you get an acceptable MOS score for VoIP services. And that means 40% of the time, you're not going to be able to deliver the quality of service for VoIP or real-time collaborative applications that an enterprise is going to command and demand. And so while this has low cost, while it has high capacity, the poor performance and the unpredictable nature is going to keep your enterprise customers from embracing this. And so one of the services and one of the products, I would say, that we enable service providers with is this new platinum tier of broadband. And this, when you add in all of the remediation that I've talked about, the ability to do forward error correction and dynamic packet steering to all of these branch locations, irrespective of what transport is connecting the branch locations, irrespective of what operator is providing those connections, now you're able to provide a much higher quality service. And in our case, you can provide MOS scores that are suitable for enterprise traffic 99% of the time, actually 99.95% of the time. In addition, if you couple that with MPLS, you're able to provide an augmented MPLS service that provides the same quality of service, but at much higher capacity at a reasonable cost. So I want to back up just for a second, because I know that the audience for this are the service providers. And the question is going to be, why would a service provider want to augment their MPLS with a service that generates lower revenue? And it sounds like that would cannibalize the MPLS service. And the reality is, there are certain cases where you're going to want to do this. And in fact, one of those cases would be with your out-of-network customers. So whether your network is, as an example, let's say you've got facilities in Germany and you own those facilities, therefore you're the most competitive there. But when you have a multinational customer, or even locations within Germany in areas where you don't have the strongest position with your wireline facilities, you're having to you're having to lease those last mile facilities either from your competitors in country or out of country. And if you're leasing MPLS services, those connections are very expensive. And an example that we had was there's a German operator that we're working with. They're providing MPLS service to one of the largest energy companies, and that company is leveraging MPLS worldwide. And of course, in the Middle East and in Asia, we're talking thousands of dollars per megabit for that service. This particular energy company, because of the drop in price of oil, they're looking to drive down costs. So in addition to laying off thousands of people, they're also looking to revamp their worldwide network, their wide area network. And so one of the things they are considering is how can they drive down the cost of connectivity? With our solution, this particular company can now leverage much lower cost broadband facilities from their competitors. In this case, if they're buying it from Singtel or leasing it from Singtel or leasing it from Telstra, instead of having to pay thousands of dollars for an MPLS connection, an E1 connection, they can pay hundreds of dollars, in some cases even tens of dollars per megabit for broadband services. And they just leverage the VeloCloud platform to enable that. And what they're doing effectively is they're expanding their on-net presence. And they're creating a virtual on-net because we are agnostic to the underlying transport. We are agnostic to who that operator is. And in addition, all of this is managed from a single pane of glass that the particular operator can now have complete visibility, command, and control of the entire network, including the health of that network at any given time. So they can see if a particular operator is providing suitable performance across that link.
Thank you for joining us for the VeloCloud SD-WAN for Service Providers Learning Series, Part 2, VeloCloud Service Provider Topologies and Use Cases. For more information, join us at www.velocloud.com/solutions/service-providers.